This is an introduction to the GitHub tutorial, and more generally, an introduction to collaborative development and version control with Git. Git is a mechanism that we can use to streamline collaborative software development or development of solutions if you're doing analytics, and do so with fewer errors. It also provides for version control, and these two things can be viewed as being distinct, and we'll talk more about them in relationship to one another later. Git is an approach toward collaborative development and version control, and it's implemented in many software packages. There's a Git desktop, which is a command line version of Git. The one we're going to be using here is GitHub Desktop, as well as the web page version of GitHub. And there's also a program called GitLab that deploys Git. And there are many other such software packages. Just to point out the prevalence and importance of Git, if you go into GitHub, you can find that the Python, NumPy, and Pandas packages are developed and maintained in GitHub repository. And here's a picture of those URLs. If you dig a little bit deeper, scroll down the page for each one of them, you'll see that the current version number that's been released for each of these, for NumPy it's version 1.26.0, and for Pandas 2.1.0. So when you load a particular package, a version of NumPy or Pandas, the version number is going to have been created in GitHub as a snapshot of the current status of all the components of software that were specified for that version. And here's some zoomed in version images. There's a distinction between ongoing development versus version releases, and I've tried to illustrate that on this slide. First of all, time is moving forward, going to the right as is it's conventionally represented. And each one of these circles that is not filled in represents a point in time where a software package or an analytics project has been developed. And at each one of these points in time, perhaps some bugs have been resolved, or new features have been added, or the program has been made more general. Occasionally, when the managers of this software development effort or solution development effort think that there have been enough and substantial improvements made in the program, then they specify points in time where a new version will be released. For example, here, this hypothetical software package might have a new version released designated as 1.2.14. These versions have major, minor, and even more minor version releases specified using the dots or the periods. The most major version number here is 1, then the next most major is 2, and then finally 14. And typically what happens periodically when the developers think that there have been enough new features added, or a significant number of bugs, or even one important bug has been resolved, then a new version is released. And what's represented here is the new version 1.2.15, which would be a very minor improvement over the prior version release. So there is a distinction between ongoing development, where bugs are resolved or the program is improved, and the new releases. So even when there aren't new versions being designated, the software is typically undergoing improvements. And Git certainly helps with identifying and releasing new versions of software, but it's just as important, or even more important, for the ongoing development where bugs are resolved and new features are added, even if new versions aren't created. So one question I like to ask my students when I do a lecture like this live is, have you ever caused a functioning program to be dysfunctional as you were revising it? In other words, have you ever broken a program that was working? And invariably, just about everybody raises their hand. And so wouldn't it be nice if you could revise a different copy of your code without running that risk of ruining the existing code, and not having to do things which people do intuitively, like appending V2, V3, V4, however many versions you might have of the software, and cluttering up a file folder, and then eventually being confused about what was changed in each one of those versions, as perhaps you needed to go back and find some old code that you wanted to reinstantiate into the current version. Well, Git solves all three of these problems. It saves you from possibly ruining functioning code. You don't have to have multiple copies of the code available, while still being able to go back and take a look at older versions that you had revised. And it provides a mechanism where you can comment every time you make a change in the code. So although you may not remember in your mind what was changed at each one of the epochs where new code was instantiated, you'll be able to go back in the records and check your notes. Typically, how Git development works, ignoring for the moment version control, is that there's always a main branch of your repository. And the main branch always represents code that is functioning. If you want to introduce a new feature, let's say, or resolve a bug, what you do is create a branch, which is represented by the lower line here. And this branch is, in essence, a copy of the main branch that you can change without risk of ruining the functioning program. Along the way, we'll introduce the notion of commits, where the code is changed, you like what you've done, and so you essentially save it. At some point, when you're done with your task of resolving bugs or adding features, you're going to submit a pull request, which will be a signal to perhaps somebody else who's in control of the main branch that you want your new code to be integrated into the code, the working code in the main branch. At that point, whoever's on the team would review the code, perhaps have a discussion, and then finally, when the people in charge are in agreement, your code will be integrated into the new, into the old main branch and become part of the functioning software. At that point, what's usually done is the branch is deleted because we don't need it anymore. Whatever you worked on is part of the main branch at this point. If at any point it becomes clear that whatever you're working on in this new feature branch is not going to work out, then the branch can simply be deleted and you haven't disturbed the working code that's represented by the main branch. What we're going to be doing in this exercise is we're actually going to be doing multiple branches at one time. We'll have a team member who's responsible for the main branch, and then all the other team members will create a branch of their own. Let's say if there's 4 team members, we'd have branch 1, branch 2, and branch 3. Those 3 team members will work on some code, and eventually what each of the team members worked on will be their branches will be merged back into the main branch. So that's what is up with this tutorial, and I hope that you have fun with it.